Good afternoon, students. Am I audible clearly? Good afternoon, students. Am I audible clearly? Okay. Welcome to the class. So we are starting our class with so many weeks, almost 3 to 4 weeks. So let us revise what we have studied. So right now we are in the last chapter of the syllabus. So that is the recovery system. So previously, sixth chapter was regarding a transaction, seventh chapter was regarding concurrency control, and last one is the recovery system. So here recovery system, it means that if consider our system gets failed because of any reason. So many of the failure reasons we have seen, just like system crash or logical error or internal error or any software or hardware problem. Because of any reason, if system gets failed, then how we can recover our data? So the way we are preserving our records, those are used in order to recover from the failures. So there are two steps are carried out. First one, that is in the regular execution, whenever we are performing any operations, we are keeping a track that which operations we are performing. That is the normal steps which are taken during the execution, that in case if failure is there, then this data can be used for a recovery. And whenever we are resuming after the failure, at this point how to use those data in order to recover our system. So this we have seen in case of our first, there is a recovery system. So here we had not studied any of the algorithm, etc. So now only we have seen few of the operations like readx, writex. This already we have seen in case of transaction also. That here this is my disk where my secondary storage, where my database is stored. Then from that database, we are bringing data into the buffer, which is a part of main memory or primary memory. And A, this will be read into a block, that is a complete, not only a single data item is read, a complete block, wherever the data item is stored, that block will be read into the buffer. Input A, it means that this operation is with respect to the CPU, that is a processor, and then input, it means that this A is acting as input to my operation. Then from there, transactions can access those data items, perform their transactions, and again write back results to the buffer. And from buffer, wherever it means periodically or after the modifications, those data will be written to the disk. Okay, so these are the steps which we already seen. So this was the example of data access. So read exit means that whatever input item we have taken, a local copy for that will be created as per the transaction. And why it means that whatever the changes done by the transaction are there, those will be returned to the buffer. And from buffer, complete block will be returned to the disk. So here, whatever input and output operations are there, these are with respect to the memory block. Okay, so these are not modifying a single data item or single record or etc. So these operations are with respect to the memory block, which is fixed. It means 1 KB or 512 MB or 516 KB, etc. So in that way, this read and write size is fixed. But wherever it is needed to the transactions, those transactions are accessing items by using a data item only, not by a block. Okay, so it means in a single block there can be multiple data items which can be accessed by multiple transactions. So that was the point which I wanted to mention here. So this was regarding the data access. So previously we have seen uh, yeah, previously we have seen the problems that which can be lead to a failure, that transaction failure, system crash, or disk failure. So again, logical errors, it means that there is a problem with our program or input or whatever we are executing a transaction. In that case, logical errors can be there. System error, wherever we are cannot continue with the transaction because of deadlock, etc. Any problem can be there. So system crash, a power failure, or disk failure. unable to read the data, etc. So these are the problems which can be there lead to the failure. Again, recovery algorithm, that two parts: normal actions during the processing of transactions and actions taken after the failure. So these 2 points already we have seen. Storage structure also we have seen that volatile storage, not a stable storage. Wherever there is a power failure, it loses its data. Non-volatile survives system crashes and data is preserved even though there is a power failure. After the resume, we can see the contents. Stable storage. So this is a mythical form of the memory that is practically this doesn't exist, but we can have algorithms to implement this. Next, data access also we have seen how it accesses data. That is what is meant by read operation, what is meant by write, input and output operation. So this part during case of 6th chapter also we have seen during the transaction execution, what is meant by read X and write X operations. And now we are proceeding towards the next content into a chapter. So here main thing is that whenever we are recovering, it also preserves the properties of the transaction. It means that during the transaction execution only, the care is taken that it should follow an asset properties. So either all the updates should be done or none of the updates should be done. So this property is called as atomicity, and hence recovery and atomicity, this go in hand. It means achieving atomicity, this also care is taken by the recovery system. So there are many recovery mechanisms are there. So even though there is a failure, still it makes sure that it achieves an atomicity. It doesn't let, it means partial operations to be taken out. It always takes care that although either all the operations should be done or database should be in a consistent state before a transaction. So here, there is also one of the recovery system is there, that is a shadow paging. We are having this in much more detail. So here, this point says that, so whenever we are performing some update, so there are two copies are created. Second copy will be called as a uh, shadow copy or shadow paging. So here, this mechanism says that initially we will keep a before update, this is the state of our database. So next, it will create another database or another copy of the database, which will be called as a shadow copy. The changes will be done to the new copy. If the changes are successful, that it has reached up to the transaction commit, it means that all the changes are done to the new copy successfully. Then old copy will be get created, and whatever the latest updated copy is there, that will be acting as a database pointer. So here this database pointer is acting as a pointer to a database which holds the address of existing database, stable databases. And whenever all the updates are done, this database pointer will be moved to the new database copy. So, and whatever old copy is there, that will be get removed. So what are the advantages and disadvantages we will see during a learning of shadow paging. So here the most probably the questions will be on this question, this point, that is a log based recovery. So here anybody heard before about this log? Anyone? Has anyone heard about this log? So here, not only related to the computer, but whenever we purchase any new device or any medicine, it means where instructions are given how to use that material or how to use that machine or how to use that device. So that prescription, or we can say a manual which says us how we should use, that is called as a catalog, so which contains all the information about that device. Similarly, log here refers to the same whenever we are dealing with the database. So log, it means that this is a record book which keeps changes done on a database. So let us see. So here log refers to a sequence of changes done on database. So this is a separate file where whatever changes are done to the database, these are preserved. So let us see what is a log. So a log is a sequence of log records. Okay. The records keep information about update activities on a database. So here, wherever changes are done to the database, those changes will be preserved by this log log, and here there are number of records are available. So log is kept on a stable storage. So stable storage, it means that this refers to a third type of the storage structures where we cannot have a loss of data. So this always a multiple copies of log are prepared, and hence whenever we are recovering from a database, we always make sure that log record is available or log file is available. So that's why this is kept on a stable storage. That always make sure that this log will be available anyhow. When transaction TI start its registers itself by writing TI start to the log record. So this is the first statement written by a transaction. So here transaction can perform any operations on a database. So for uh, every statement in a transaction, log record is not available. Wherever there is a changes to a database are there, only those information will be kept into a log. For example, if I read, it means in my transaction, if I'm starting read A, and then I have performed A equal to A plus 50, then I perform A equal to A into A, or later on I have written A equal to B minus C, etc. It means any value. So can be, I can change for any number of the time during my transaction. But for these, all the statements, there will not be any responsible log record will be there. But whenever I am saying write A, okay, write A, this statement is going to make changes to my database. And hence, at this point, a log record is kept or entry is made that a transaction TI is performing changes to the data variable A with new value and old value. So, okay. So here my point is that for every statement in a transaction, log record is not available. Wherever there is a write X is there only, or changes to the database are there, only those log records will be available. So this is the format that before TI executes write X, a log record, that is a transaction TI, is performing changes to the X variable V1 and V2. So wherever this V1 refers to the old value of X before changes to the TI, and V2 will be the new value that TI wanted to write to the database. Okay, so it means whenever we are executing the transaction, there are two possibilities. Either our transaction may get success or our transaction may get failed. If it is successful, then V2 value will be written to the database. If it is failure or transaction TI get fails, then we are having the record that X was having the old value V1, and then we can write back the V1 value. It means here our recovery step is that here during the normal execution, we make sure that old and new both values are available in the log record. So based on the status of TI transaction, whether it is committed or failed, it decides whether to write V1 value or whether to write V2 value. So this was the point here, and that's why this complete log record is made available into log file. When TI finishes its last statement, it means TI is completed. So log record TI commit is returned. It means if without any problem, without any failure condition, if TI gets committed, then TI commit, this log record will be returned to a log. And hence it means two approaches are there using the log. So there can be log files can be used in two ways. First one is immediate database modifications, and second one is deferred database modifications. So let us see which are these two variations. So first one, immediate database modifications. So immediate, the name suggests that whenever we are performing changes, all those changes immediately will be reflected into database. So immediate database modification scheme allows updates of an uncommitted transaction to be made to the buffer or the disk itself before a transaction commits. So immediately after the execution of write X statement, this will make changes to our database and buffer as well. So to the disk, it may go in one stroke or it may go in that let the two transactions complete the updates and then we can write it. It means it is not decided when this will perform changes to the disk, but it will make changes to the buffer. Okay. Update log record must return before database item is written. It means here, whenever we are performing log record, so here we should update the log record, then we can go for writing the value. We assume that log record is output directly to stable storage. So stable storage, never my data get lost from stable storage. That's why this we are keeping log record into stable storage. Output of updated blocks to disk can take place at any time before or after a transaction commit. So as I mentioned, so whenever immediate database modification is done, it will make changes to the buffer copy, but those changes will periodically or maybe once in a day or twice in a day or hourly or by 10 minutes, etc. In this way, it means processor will decide when to perform changes to the disk itself. So in this way, these will changes will be carried out to the disk. So it is not fixed that my transaction is committed. It means that all changes will be written to the disk. No, changes can be there, but those will be available into buffer only. So the way my transactions are committed, it is not mandatory in the immediate database modification that yes, changes will be also reflected into disk. It is not mandatory, but changes will be reflected into buffer copy. Even though transaction is not committed, consider TI has performed any changes to the A value, return back to the buffer, release the data item A, and another transaction T2 can use the same data item A. It means even though T1 is not committed, still T2 can use the updated copy of A. So this was the immediate database modification. The order in which blocks or output can be different from the order in which they are written. Okay, so if from reading from a disk, if I'm reading 1, 2, 3, 4 blocks one by one, while writing, it is not necessary that I will have 1, 2, 3, 4 in the order. I can write first four block, I can write next second block, or I can write first block and third block. It means it is not mandatory the way we are reading, the same way we are outputting or writing. At all, there is a no any such restriction. But here the next one, this was the immediate database modification, and next one is a deferred database modification. So this scheme performs updates to buffer or disk only at the time of transaction commits. Uh, Here, deferred database modification scheme performs updates to buffer or disk only at the time of transaction commit. So this was the change in immediate and database modifications. In immediate, we are immediately performing changes. In case of deferred, only after the transaction commits, then only we are writing this changes. So, but it is having override that it should keep a local copy. So transaction commit. All transaction is said to be committed when its commit log record is output to a stable storage. So whenever we are having this available to the stable storage, then only we can say that transaction is committed. So previous log records of transaction must have been output already. Writes performed by a transaction may still be in buffer whenever transaction commits and may be output later to the disk. So this was an example of a immediate database modification. So here, first, so this output, it means that this we are writing to a output. It means write this is operation with respect to the buffer and output is operation with respect to the disk. So this is a log record that T1 started. T1 has performed changes to the A. That previously this was having 1000 value. Then new value is 950. Then T0 transaction has performed changes to the B as well. 2000 value is the old value. 2050 is the new value equal to. So right, it means that these changes are done to the buffer, not to the disk. Okay, disk refers to the actual database and buffer refers to the temporary storage. So A's new value will be updated, B's new value will be updated. So this will commit. Commit, it means that this is holding a correct value, that buffer is holding the correct value. Then T1 is started. Then this has performed changes to the C, that previously old value is 700, new value is 600. So this will again write changes to the write buffer. So immediate database modification, it means that immediately write this results to the buffer. And then here output operation is there. Output, it means that this wherever my data item B is there, that block will be returned to the disk. Wherever my data item C is there, that block is also returned to the disk. And later, the block containing data item A is returned to the disk. So here, the writing of data items. Here, A got first updated, B got second updated, and C got updated third. Still, we are having a different order for the block writing. It means T1 commit changes are done after the T1 commit has been done. So this was the only point. So please go through this example for a while. So, okay, clear with this example? Now let us move to the next, concurrency control and recovery. So this is again an repetition of the same, that is with concurrent transaction, all transactions share a single disk buffer and single log. So here a log record is not different for the every transaction. Log record is a single file which is accessed by the multiple transactions. So that is whenever we are resuming from the failure, we need not to search that which way the transaction started and for which we need to search the log record. No, there is always a single log file is there. And same we are accessing for a recovery. So buffer block can have data items updated by one or more transactions. So as I mentioned that here, whenever we are performing the operations, here operations are done on data item. But whenever we are reading and writing with respect to the data items, we always read and write from the buffer, not from the disk actually. So I would still like to refer this figure. Yeah, this one. So here input A, it means that this is completely reading a block containing data item A. Okay. So not only A, there can be multiple data items will be there in the same block. If those data items can be accessed by multiple transactions or may not be accessed by the multiple transactions, but these are anyhow will be input or read into the buffer. Yes, but from the buffer, simply a data item can be read by a transaction. Transactions input is always in terms of a data item, not in terms of a memory block. But when it respect to the memory, that is disk operations are there, these are always done in terms of a blocks only. It is a memory block. So size is always not fixed. This depends on a machine, how much capacity it is having. So generally the size in terms of 1 KB, 2 KB or 512 bytes, etc. In this way, the size is there. So whenever we are moving the blocks, it can have uh, more than one data items also. More than one data items, and those data items can, that is considered, we are having in input A, there are four data items X, W, Y and Z. So X can be accessed by T1, Y can be accessed by T2, Z can be accessed by some another transaction. So in this way the changes or variation can be there, and those transactions will again perform changes to the buffer, and modifications hold by those all transactions will be written back to the disk. Okay, this is how this continues with the execution of a transaction. So we are here, concurrency control and recovery. So we assume that if a transaction Ti has modified and data item, no other transaction can modify the same item until Ti has committed or aborted. Okay, so still the block is in the buffer, that data item is into the buffer and Ti is accessing. So Ti is it, if it is accessing, then that item will be locked and will not be made available to the any other transaction. So if Ti has committed, then other transactions can use that data item. But if Ti is aborted, then other transactions will receive the old copy of that data item. Okay, so here whatever the changes done by the TI will be there, those will not be available to the other transactions as TI is aborted. But if TI is neither committed neither aborted, in that case that data item is not made available. That is, updates of uncommitted transactions should not be visible to other transactions. Otherwise, we have to go for the cascading rollbacks. So this already we have seen in case of two-phase locking protocol. If consider Ti has performed any changes to the A, before commit if T2 is accessing and because of by chance Ti get aborted, then we need to undo the T2 as well. Okay, so this was the problem. So here we, it means we follow the strict two phase unless and until we reach to the Wherever writes exclusive logs are there, we carry out them to the commit of transaction. So log records of different transactions may be interspread in the log. So here, this last statement it means that if TI T0 start record is there, it is not mandatory that before my T0 commit is there, no other transaction can start execution. No. T0 started, then TI can start. Before T0 commit, any transaction can be started or committed. It means any transaction which are started before T0 also. Interspread it means that in between other records can be there between the transaction start and transaction commit. So undo and redo operations. Undo the changes done by a transaction. Redo whatever changes we have done, we will commit those changes. So this was the meaning. So this was regarding the deferred database modification. So deferred database modification, this step is done whenever deferred, it means delayed write is there. Delayed changes are done to the database. So let us see how it says. Undo TI restores the values of all data items updated by TI to their old values, going backward from last log records to TI. So this is how we are undoing. That is, we will go to the log, check what is the old value, and those old value will be written to a disk. Each time a data item exceeds restored its old value fee, special log record TIXV is written out. Okay, so even though we are undoing, those also preserve into log record. That is, undo operation is done. When undo of a transaction is complete, a log record TI abort is written out. So after undo, we again add the record that TI abort is done. Redo TI that redone the changes. So in this case, we need not to have any log record. That delayed write it means that we lately is only writing the changes. So here we are not keeping the record that yes, we have written a new value, we have written a new value. No. Here, no log is required, but directly it goes for the changes to the buffer. Sets the all values of data items updated by TI to the new values going forward from first log record to the TI. Recovering from the failure. So, how we can start recovery from the failure? So here, whenever it means during the normal execution, we are keeping a log record. So consider that at any point of time we are having a failure. Then we resume. It means after the failure, now we wanted to start a recovery phase. Then in that case, here we need to go to the log record and search whether we are having the pairing of it means any transaction T0 start and TI start, TI commit or abort. It means whatever ending record is there, whether that is available. So let us see how it starts. So TI transaction TI needs to be under. It means whatever changes done by the TI are there, those we need to undo. If log record contains a record, TI start. If TI start is there and we don't have any record, neither TI commit, neither TI abort. It means that transaction had not reached to the end of its phase. If transaction is incomplete, then we have to simply abort that transaction and then undo the changes done by that transaction. This is fixed that if transaction is incomplete, we have to abort that transaction and undo all the changes. Transaction TI needs to be redone. Okay, redone it means that let the whatever transaction has done, let us save those changes. If the log record contains TI start is there and also TI commit is there. So if TI commit is there, it means that transaction has completed successfully and whatever the changes to be done by the transaction are there, let those changes carried out. And if transaction TI abort is there, it means that changes are not done to the buffer. So do not make any changes to the disk also. If transaction commit is there, whatever the changes done to the buffer are there, let the system write to the disk. If TI abort is there, it means no changes are done to the buffer. Let the buffer write the old value to the disk. So this is how this it means redo is done. Here simply the main concept is that if we are having incomplete transaction, simply rollback transaction, and rollback it means that undo the changes, redo only commit is there or abort is there. So this is the same, repeating the history, whatever steps we have carried out, the same will be done. So this is a example where we will see which steps to be taken on. Okay, so there are three cases, A, B, C are there. So first case, that this is my log record after the failure when I start to recover my system. So first is the option that T0 start is there, T0A. This is an immediate database modification that immediately the changes are written to the buffer. So in that case, we are having T0 start, but no, neither matching T0 abort is there, neither T0 commit is there. It means that the first option is having that first transaction, whatever the first choice we are looking at, this is an incomplete transaction. So incomplete transactions are always aborted. So in that case, we need to undo the changes done by a transaction. So T0 has performed changes that previously A's value was 1000 and this has changed the new value to 950. Then whatever the effect of this statement is there, we need to undo those changes. It means we have to write the old value. So for this purpose, we have to write this old value to a log record. That T0 transaction will write A's value, that is old value, as 1000. This is for the A. Next, this is okay. One point I forgot to mention. Here, whenever we are writing from looking for the log record, this always goes from the end to the start. It means from the reverse direction, it starts reading. This means that this will first read a last statement, this one, T0B 2020. So this first will perform changes to the B. Okay, so this B's old value will be written, A's old value will be written, and T0 start is there. It means that this transaction had not aborted yet. So this will right, T0 abort will be written to the log file. So this is how the log recovery steps are there. So here we have recovered from the failure, that we have decided that even though the transaction was failed, now we will, as a recovery system knows that this transaction cannot be committed. So whatever the changes done by the transaction are there, in order to achieve the atomicity, we have written the old values safely to the buffer. So this was the first case. Now let us start with the second case. T0 start is there, T0 commit is there, and T1 start is there. So from the reverse direction, T1 C 700 and 600. So equivalent undo statement, that reverse statement of that changes. So this will be written, and T0 start is there, but no matching T0 T1 abort or T1 commit. It means this transaction is incomplete. So it will write this abort statement, and then T0 commit is there. Okay, commit is there. It means that this transaction has completed its execution. So whatever the changes done by this transaction are there, those need to be reflected on a database. So for this purpose, this will allow to perform modifications to a transaction. So here we make conclusion that yes, this transaction has committed. It means this changes can be done to a database. So here redo it means that transaction T0 is committed. It means that those changes should reflect on my database. So here we need not to write any other matching statements to a disk, not any matching statement to the log. So this transaction has committed. It means T0 start is also there and T0 commit is also there. So whatever the changes done by this transaction are there, those are valid changes. And we have to achieve the atomicity. It means this is committed, it means that this is the changes can be done to a disk also. So no any equivalent changes will be done, or no any need of undo is required. So this will redo. Redo it means that changes are done to the buffer, those can be written to the disk also. Okay, so this will write out this records to a disk. So this is a it means this is a way how this handles partial transaction or complete transaction. And next one is a third case, that T0 transaction start and commit is also there, and T1 start and commit is also there. So in that case, both transactions has completed and changes are done, that is successfully executed. So then we need not to write, that is whatever the changes done by those transactions are there, those are valid, and it will perform the redo for T0 as well as T1. So please go through this slide for once and let me know if you are having any doubt in this in your operations. So okay, now let us go to the next slide, checkpoints. So here, simultaneously there are many transactions executing on a executing in our system, and here we have taken simply transfer of 50 or 50 rupees from one account to the another. So there can be a transaction which are much more lengthier. It means hundreds of statements are there, or committed transactions are there, or similarly say 10 to 25, or maybe hundreds or thousands of transactions are executing. So each time, whenever we are facing any failure, we cannot read the complete log file. To answer that, up to now, I have executed 100 transactions on my database. Out of those hundreds, consider that 90 transactions effect is already there on a database. Okay, so as soon as I start my 91st transaction, 92 is also started before commit of 91, and 93 is also started. Sorry, consider that from 91 to onwards, changes need to be done to database. It means 90 transactions changes are already there on a database. So whenever I'm recovering from the failure, I cannot expect that I should check all the 100 transactions whether those effects are reflected on database or not. Okay. So here, for this purpose, we always use a concept of checkpoints. Checkpoints, it means that this is a point up to which changes are already there on my database. So redoing or undoing all transactions recorded in log can be very slow. It means we cannot expect that let us check whether undo or redo of all the transactions. So for this processing the entire log is time consuming if system has run for a long time. Then we might unnecessarily redo transactions which are already updated their updates to database. So this was the problem. So for this purpose, we periodically perform checkpointing. So let us see what is meant by a checkpointing. Output all log records currently residing in main memory onto the stable storage. Okay, so for this purpose, whatever there is in main memory, that is a buffer is available. Let all the changes reflect on a stable storage or onto the disk. So whenever those changes are reflected onto the stable storage, transactions will be kept waiting. That transactions will not be allowed to modify the copies. Okay, that was the point. Output all modified buffer blocks to the disk, the same. Write a log record, check EL. Okay, checkpoint EL. So this is a log record which we are adding to the log onto stable storage, where L is the list of all transactions active at the time of checkpoint. Okay, so it cannot happen that let us stop all the transactions. It means simultaneously two or three or multiple transactions can might be executing. So whenever we wanted to perform the checkpointing, we cannot wait to complete those to finish. In between another transaction may start execution. We cannot keep on waiting. So we will keep a list that yes, at this point of time, these many transactions are active. So this list will be available and this L list will be kept as a checkpoint that during this checkpoint those transactions were active. And whenever this log record is written, it means that whatever the previous transactions are there, already those changes are reflected to the disk. That is a stable storage. And whenever my system starts recovering from failures, whenever my system starts recovering from a failure, it will check its records up to the last checkpoint only. Checkpoint that up to this point, previous records are all checked. Only up to this point, we need to check the current records. Okay, that was the meaning. So during recovery, we need to consider only the most recent transaction TI that started before checkpoint and transactions that started after the TI. Scan backwards from the end of the log record to find the most recent checkpoint. Most recent checkpoint EL record. Only transactions that are in EL or started after the checkpoint used need to be redo or undo. Transactions that committed or aborted before the checkpoint already have their all their updates to the stable storage. So this will save us lot much time and this will not ask us to, in order to recovery system to work, that we need to consider all the transactions whatever we have executed now. So some earlier part of the log may be needed for undo operations that we need to check whether continue scanning backwards till a log record TI start is found for either, every transaction TI in here. So here we need to check whether TI start is there. So parts of log prior to the earlier TI start record above are not needed for recovery, can be raised whenever desired. So this was the point. It means this is an example of checkpoint. We can start. So here at this point checkpoint is done. So and if at this point we are having the failure, then here this transaction TI T1 was started and completed before the checkpoint. It means already its changes are done to the database or reflected to the database. At this point, this will keep the list that yes, T2 has been started or T2 is active. So this checkpoint will hold that yes, T2 is the L containing the list T2. And after that, whenever the system failure is there, so from the recovery, this will start scanning from the backward direction. So this will check whether T4 abort and commit is there. If not, this will roll back, ask to roll back this T4. If T3 is as T3 has completed successfully, so this will redo the changes of T3. Also, it will perform the changes done, redo the changes done by the T2 as T2 also has been started and completed successfully. So redo the changes done by the T2 And here is a checkpoint. So this will come to that whatever the changes previous are there, those are already reflected, and in this case this will ignore the T1 transaction. Okay, and as there is no endpoint for the T4, as T4 is not completed at the time of failure, so this will undo or roll back the T4. Next, logging recovery algorithm. So this is the actual working of logging. Logging during the normal operation, T1 start at the beginning of the transactions or whenever transaction starts. So whenever every transaction start, TI begin we are writing. So this begin statement will result into TI start record into a log file, and there will be next record which we will add to the database log file, that is a TI transaction has performed changes to the XJ variable where V1 is the old value and V2 is the new value. So this uh, update or this log record is a result of always a write XJ operation. Okay, so any of the statement into a complete transaction will not write a log record. Only there are three statements are there which will perform the log entry: transaction begin, transaction end, and write X. Okay, these are the three statements only which are performing or added to the log or which will result into log entry. Transaction rollback during normal operation. So here, let the transaction TI be the transaction to be rolled back. So scan backwards from the end for each log record of TI of the form, this one. So here, whenever we are starting scanning from the backward direction, so this will check whether any such record is there. Any such record, it means that this TI is not yet completed. Neither abort is there, neither commit is there. It means that TI is not reached to the end of the transaction. So for this purpose, we need to perform the changes. So undo it means that we have to write the old value. So we will write V1 to the VJ. Whenever this changes in done, this will also add the log entry. So this is acting as a compensating log record. Compensate means that previously we have some taken action, and to correct that action, we are taking some equivalent other action. Okay, so this will be called as a compensation log record. So once we found with the TI start, it means that all the changes done by the TI are done, and then we can write the TI abort. Okay, this log entry will finish the execution of T1, and we can say that TI has been rolled back. So this is again a repetition. So I will skip this part. Undo and redo phase. Yes, this is one of the examples where we will decide what to be done. Okay. So here, beginning of a log. So this we are starting with the beginning of log. This was older, and so up to T0 abort. Up to this point, we are having a. At this point, we had a system crash. That is, this was the end of the log record during the crash. So let us see from the start. T0 start is there. T0B changes to the B variable by T0. T1 is also started. So checkpoint, this will keep the track that yes, T0 and T1 are the active transactions during the checkpoint. T1C changes, T1 commit, T2 start, again another transaction started. T2 has performed some changes. T0, that T0B 2000 is written. That is a compensatory log record will be there. So as this has performed some changes, so this is writing and compensatory log record, and T0 abort is there. Abort is there, it means that T0 is also completed. Okay. So now let us assume that we have a system crash or failure of a system. Then we start scanning from the backward direction. T0 abort is there. T0 abort is there, it means that this transaction has failed. T0 rollback is there during the normal operation begins. So T0 rollback is completed. Abort is written, it means that this has completed its execution, and whatever the new values it has written, it has also written replaced with the old value. That is the meaning. So there are no changes. It means for T0, we need not to take any corrective action. Okay. So whatever changes done by the T0 are there, those are valid changes, and we need not to perform any corrective steps to correct the T0. T0B 2000, for this purpose also, we need not to write any of the record. Now T2. T2A 500 and 400. This means that T2 is not yet completed, and hence we need to abort or roll back this transaction. So for this purpose, we write an compensatory log record that we need to undo the changes done by T2. So T2 has performed changes to the A. It has written the new value 400, but it need to be replaced with the old value. So this will write a compensatory log record. Okay, after T0 abort. So after recovery, this will start this record, or this will write this record. Next, it has found T0 start. It means here only T2 was started. So then we can make a conclusion that yes, T2 need to be aborted. So T2 abort, this record will be added to the log file. Then T0 commit is there. So again, need not to perform any. So here for the redo, we are having two transactions, T0 and T1. As for T0, we are having T0 abort, and for T1, we are having T1 commit. So we need not to undo these changes. Only T2 also, T2 only we need to undo. And already we have done this. So undo list will be only T2. So T1. So in this way, this will again start with. So it has reached T1 commit will be there. T1 C 700 and 600 will be there. So checkpoint T0 and T1. So it means that it need to check whether uh, that during this checkpoint T0 and T1 were the transactions which were active. So this will check that yes, T1 start is also there and T0 start is also there. So this will only access the log record up to the start of these transactions. As soon as it finds out the T1 start and T0 start, it makes sure that yes, these two transactions are completed, and those changes are also done to a database, and hence those will be added to the redo phase. Done. So there will be only one transaction which need to be undo. That is a T2. Log record buffering. So we know buffer is a temporary storage. So whenever we are performing any changes, those log records will be also buffered. It means log records will be also made in buffer. So let's keep this. Yes, buffer management. Buffer manager management is required as we are performing. It means many data items will be accessed for a transaction. We cannot guarantee that all those data items will be available into single block, or simultaneously only one transaction is executing. Multiple transactions are executing. Multiple transactions are accessing multiple data items, and those multiple data items can be available into multiple disks. Sorry, multiple data blocks. And hence, whenever we are executing a transaction, for a single transaction, it might happen that we are accessing multiple data blocks or memory blocks. Those all will be taken into a buffer. So buffer is a temporary storage, and we know that whatever the main memory is there, it is the most costly memory. Okay, this is a RAM or primary memory, or also called as a main memory, to which a CPU accesses in order to execute any of the programs. So here this is always a costly memory and hence we cannot afford that complete database or many blocks, unnecessary blocks we should take into buffer. So for this purpose, we are always using a concept of virtual memory. Okay, so virtual memory, this means that a block by block, a data items are read into a complete, block by block, a complete database is read. For example, even though database size is 1 GB or 2 GB or maybe much more than, but still by using a main memory of few MBs, I can access that 1 GB. That from 1 GB, whatever only part is required, only that will be brought into buffer, will be passed to the transaction. Whenever transaction demands some another data item, again a request will be sent to the database from 1 GB, saying that data block, and those will be again written. It means accessed by a transaction. So transaction seems that here, a complete 1 or 2 GB has been taken as an input into a main memory. So, okay. So for this concept is called as a virtual memory. It seems that there is a space of 1 GB or 2 GB into a buffer, but it's not. Here we are reading in terms of pages or blocks into page by page or block by block. So again, whenever we decide to manage, so frequent replacing the pages, that is not preferable. So for this purpose, there are some page replacement algorithms are there that in detail we need not study because here this is not a part of focus here, but only here in area of real main memory reserved for database or in virtual memory. Implementing buffer in reserved main memory has drawbacks that memory is partitioned beforehand between database buffer and applications. Limited flexibility is there. Needs may change, or although operating system knows best how memory should be divided up at any time, it cannot change partitioning of the memory. So okay, for this purpose, we are using the concept of dual paging. So let us see what is meant by dual paging. Ideally, when OS needs to evict a page from a buffer, it should pass control to a database, which in turn should check. It means output a page to the database instead of swap space, making sure to output log records first, and if it is modified, and release the page from the buffer for the OS to use. It means whenever any page we wanted to bring or input into a buffer, check whether whatever the buffer containing the page, that page is having changes. If changes, output those changes to the disk, that write back those changes to the disk, and then whatever new page is there, we can replace the existing page with the new page. So here we are always using a limited the space of the memory, and that's why it's called as a buffer management. Next, failure with the loss of non-volatile storage. Non-volatile, we assume that this storage always available. So if consider there is a failure with this also, we need to keep the backup. That is a dump file periodically. The entire contents of database to a stable storage. So this will be called as a dump file. So no transactions may be active during the dump procedure. Just like whenever we are keeping the backup, we need not to perform any changes to the database, and output all records currently residing in the main memory to the stable storage. Output all buffer blocks onto the disk. Copy the contents of database to the stable and output a record dump to a log on stable storage. So this dump says that yes, we have updated database. So whenever there is a failure, we can take the backup from the dump file, restore database from the most recent dump, consult the log and redo all the transactions committed after the dump. Okay. So now we are moving toward the second last point, that is our remote backup system. So remote backup system, it means that whenever we are keeping the database backup, it is not mandatory that we are having the secondary space or we are having another machinery near to us on which we can keep the backup. But here, remote backup system, it means that remotely we are maintaining a database storage. So another copy of the database storage. So this will be called as a remote backup system. So this backup, so I don't know whether you are aware about this, but remote backup system, many of the server systems, these allow for the remote backup. It means whenever we wanted to store our database, we will pay to them that you keep my data or you keep the backup of my data, and whenever I will be asked, I can take the backup from that. So on the yearly or monthly basis, the contact can be done. So this is again one of the growing as we are increasing a lot much data through social media or through the courses, etc. So this is one of the main thing today we can see this. A remote backup system provides high availability by allowing transaction processing to continue even if primary site is destroyed. So if consider we are keeping the log records also onto the backup. If this primary system also got failure, then we can take a backup from the new machine and then can execute with the transaction or start with our system. So here detection of the failure. So how we can detect whether our primary system has been failed? So backup site must detect when primary site has failed. So this backup system must check whenever my primary system is on or whenever there is a failure. So distinguish primary site failure from link failure maintained. Several communication links between primary and remote backups are available. So heartbeat messages, it means acknowledgement messages we can check. Transfer of control. To take over the control, backup system first perform recovery using its copy of its database and all log records it has received from a primary. Thus completed transactions are hidden and incomplete transactions are rolled back. When backup site takes over processing, it becomes a new primary system. And to transfer control to old primary, when it recovers, the old primary must receive redo log records from the old backup and apply old updates locally. So time to recover. To reduce delay in takeover, backup site periodically process redo log records, in effect performing recovery from previous database state. Performs checkpoint can detect delete earlier parts of the log. Hotsphere configuration permits very fast takeover. Backup continuously processes a redo log record as they arrive, applying updates locally. When failure of a primary is detected, backup rolls backup incomplete transactions is ready to process new transactions. So already due to remote backup, distribute database system with replicated data. So distributed system, it means two copies we are maintaining and both are active simultaneously. So distributed database, it means that some part of the database will be available on first machine, some part of the database will be available on second machine. So both are acting as a active simultaneously. Changes done on first machine will be reflected to the second one, and changes done on second will be reflected to the first one. And whenever any transaction willing to access any other data item, it should log data item on both the sides. That is the main point in distributed system. So this is the input and output operation. So already we have seen this. So this also we have seen. This also we have seen. This also. Now we are moving towards the last point in the syllabus, that is a shadow paging. So shadow, it means that exactly the reflection of ours, but paging refers to a page its own reflection. Okay, so shadow paging is an alternative to log-based recovery. So always we are keeping a log record whenever we are performing changes to the database. But this shadow paging is having another solution to the recovery system. This scheme is useful if transactions execute serially. Okay, so the main idea is maintain two page tables during lifetime of a transaction. The current page table and shadow page table. So these two page tables maintain that which page is containing into which data, that which data item is containing into which table. Store the shadow page table in non-volatile storage such that the state of the database prior to the transaction execution may be recovered. Shadow page table is never modified during the execution. To start with, both page tables are identical initially. Only current page table is used for data item accesses during execution of a transaction. Whenever any page is about to be written to the first time, okay, a copy of this page is made onto an unused page. The current page table is then made to point to the copy. The update is performed on the copy also. So this is an example of a page table. So this is my page table and these are the pages on the disk. So this will keep the track that yes, this is address of this page, etc. Okay, and this is an example of a shadow paging. Okay, current page table, it means that right now this is holding the addresses of all the pages. So whenever any new page is created, okay, so we are having the page number 4. So this page we are creating, then only current page table will hold. And whenever all the changes will be done, the changes will be made available here also. That is in the shadow page table also. Okay, so to commit a transaction, so which are the steps taken during a shadow paging? To commit a transaction, flush all modified pages into main memory to disk. That this will be containing all the changes done by transaction. Output current page table to the disk. Make the current page table in new shadow page table as follows. Keep a pointer to the shadow page table at fixed known location on disk. To make the current page table, new shadow page table, simply update the pointer to point to current page table on disk. Once a pointer to shadow page table has been written, transaction is committed. So here we are talking about this no, wait, let me go to that page. Yes, this one. This is exactly referring to a shadow paging. So here, old copy of our database is there. This is the new copy will be created for database. That is exactly the same copy. Changes will be done into this copy, and then whatever database pointer is there, so this will be made pointing to the new database whenever a transaction is submitted. And whatever old copy is there, that will be deleted. And whenever again new update is done, another copy will be created, new copy will be created, changes will be done to this new copy, and whatever old copy is there, that will be get removed. So here the main thing here is that if consider during the transaction execution, if my system get crashed, okay, still we are having the old copy in a consistent state. Okay, so here a transaction uh, which are not committed, those undo changes will not be done to this. So here the main drawback of shadow paging is that this is used in case of a serial execution, that is those transactions which are executing serially. It means one by one. If one transaction has committed changes to this database, then another transaction will use the same database. Okay, so but for this purpose, when a new transaction is started, a new copy will be created and changes will be done on new copy only. It means if there are T1 and T2 transaction has started, T1 has performed changes to the new database. Then whenever T2 is starting, this old copy will be deleted and new copy will be created, and T2 will perform changes to the new copy only. Okay, it means that if T2 is unable to complete, then we are having the old copy which is pointed by a database pointer. and even after the update, it means update is complete, that is up to the commit, then only database pointer will point to the new copy. Okay, so let us see the changes. Yes, this is the page table and pages from this. Okay, current page table and shadow page table is there. But here, as new page has changed, okay, this is a page is changed. So if consider this is a correct, that all the changes are done, all the transaction execution is successful, then the shadow page table will be get removed. Okay, and new copy will be created. That new changes will be held by this new copy, and this will be acting as a shadow page table now. And then if this has completed, then this will be acting as a current page table. And if these changes are unsuccessful, okay, if those changes are unsuccessful, then simply this page will not work, only this shadow page table will acting as a current page table. Yes, here we are. Flush all modified pages in main memory to disk. So it means whatever the buffer contents are there, we are writing back to the disk. Output current page table to the disk. Okay, so whatever current page table is there, that also we are writing to the disk. That is a stable storage. Make the current page table the new shadow page table as follows. So how we can make the current page table to the new shadow page table? Keep a pointer to the shadow page table at fixed known location on disk. Okay, from the disk we will keep a fixed location, that yes, this is my shadow page table. To make current page table the new shadow page table, simply update the pointer to the current page table on the disk. Previously, whatever new shadow was there, now make it to the current. Once pointer to a shadow page table has been written, transaction is committed. Then we can say that yes, if this pointer updation is done, then we can say that the transaction has been committed. So no recovery is needed after a crash because we are having the old backup. So new transactions can start right away using the shadow page table. And if we are having a successful execution, then we are using the shadow page table. Pages not pointed to from current shadow page table should be free. It means which are not used, those can be free. That is, garbage should be collected. Advantages: no overhead of writing log records, recovery is easy, that is trivial. But disadvantage is that copying complete database can be too much expensive, and too much space is also needed. Even though there are small changes done by our transaction, still we are updating a complete database. Okay, that is not a preferable operation. That's why this is rarely used. Commit overhead is high even with the above extensions. That is B plus tree extensions. That is, instead of copying the entire database, we can make a tree, and only those data items which were changes are done, only those copy also we can maintain. So that can be this option, but still this can be expensive also. So here data can be get fragmented, that related pages may be distributed on multiple disks. After every transaction complete, database pages containing old versions of the modified data need to be garbage collected. Okay, it means explicitly we have to collect a garbage wherever old values are there. Okay, this was regarding the log records. So here, please, if you are having any questions on mentioned points, you can ask me.